This was a quiz on simplifying rational expressions and solving rational equations. When I talk about rational expressions, I'm talking about these fractions that have variables in them, polynomials and numerators and denominators. Let's take a closer look. But look, as we do these problems, understand we're dealing with two different things. Looking at problem number 1 and 2, notice that there's no equal sign. All right, we're not solving an equation. We're not going to come up with n equals something. That's not what we're doing. We just have an expression and we're simplifying it. That's it. As opposed to number 3 and number 4, see the equal sign? These are equations. Our goal is to get all the way down to n equals 7 or n is equal to -2 or whatever it is. Alright, so please notice that these are different problems and they will be treated differently. Students mix those up a lot. Alright, so number 1, there's no equation, so we are just simplifying this expression. We are subtracting these two fractions. The key is we're going to need like denominators. You should factor anything that you can so you can see what you are dealing with. So I've got n plus 1 over GCF here, so that's 2 times n plus 4. Okay, and then minus 7 over 2. Now, to add or subtract fractions, you need like denominators. So that's what I'm going to do right now. Let's see, which color should I use? The left denominator has a 2. The right denominator has a 2. So that's cool. To be the same, the right denominator will need this factor of n plus 4. We'll have to do the same thing to the top. That way we are really just multiplying by 1. Because anything over itself is just 1. So we didn't really change anything. So it's legal. Now we can subtract. And the way we subtract is we keep the common denominator. So our common denominator of n, 2 times n plus 4. And then we go ahead and subtract the numerator. So we have this n plus 1 minus 7 times n plus 4. Okay? We just sort of put these together, if you will. So now we'll just simplify this. There's nothing in front of these parentheses, so I can just erase them, and this becomes n plus 1. But this -7 is going to have to be distributed, so that will be -7n minus 28. Okay, and I'm just going to leave this as 2 times n plus 4 for now. Combining like terms, I've got n and -7n, so that's -6n. Positive 1, -28, that is -27. Okay, and that's over 2 times n plus 4. Okay, this might be the answer. I see that there's a GCF here of 3, or -3. But that's not going to cancel out the 2 or anything. So really, this is the answer. So let's go ahead and just write that down. I feel like, so I've got -6n minus 27 over 2 times n plus 4. Now let's write the restrictions. Alright, the restrictions are easiest to see right here in this blue. Just ignore this part, but n cannot be -4. That's the only restriction. Alright, so I'm just going to put a box around this. So this is the solution, but the excluded value is worth mentioning. So n cannot equal -4. Alright, so that is the answer to number 1. Alright, if you wrote this as 2n plus 8, that's fine. Okay, how about number 2? Well, we need like denominators, don't you know? Let's treat this, v minus 1, that's a factor. V minus 3, that's a factor. We're going to have to give each side the factor that is lacking. So this has a v minus 1 on it, so I'm going to give this side v minus 1 as well, in the numerator and the denominator. This side has a v minus 3, so I'm going to have to give this side a v minus 3, in the numerator and the denominator. Okay, so now I have like denominators, so I can add. My like denominator is v minus 3 times v minus 1. Okay, that's the common denominator. Now in the numerator, I'm going to distribute right here. So that's going to give me 5v minus 15. And then I'm going to distribute this right here as well. So that's going to give me plus 4v squared minus 4v. Okay, then I'm going to combine some like terms. And these are the only like terms, here and here. Okay, so I'm also going to rewrite the numerator in standard form. So first degrees first. So I have 4v squared. 5v minus 4v is 1v, or just v. And then minus 15. Okay, I combined like terms and wrote them in order, standard form. And that's over v minus 3 times v minus 1. Now, I should attempt to factor this numerator just in case it will cancel out one of these factors in the denominator. So I'm going to attempt to do it. There's no guarantee that it is factorable, but I shall try. Okay, 4v squared. So I'm going to start with 2v and 2v. Let's see how that goes. But if this doesn't work out, I'll go back and try 4 and 1. Although, if it turns out to be this, nothing's going to cancel anyway, so it's sort of a waste of time. Except for then we'll know to stop looking. So, 15. 15 might be... Okay, so 15 could be either 3 times 5 or 1 times 15. 4 is either going to be 2 times 2 or 1 times 4. So a lot of things to play around with. Let's start with the 3 and the 5. Okay, inner plus outer has to equal middle. Alright, so inner, I have 6v. Outer, I have 10v. Out of this, I have to get a 1. No, there's no way to get a 1v out of this, no matter how I pick the signs. So this is not working out. So 3 and 5 is not working right now. The 1 and 15, well, that's just going to be even worse. If I put a 15 here, that's like a 30, and a 2, that's not going to work. So basically, the 2 times 2 option is not working. So let me try the 1v and 4v option. Okay, and of course 1v is just v. So let's try v and 4v and see how we do. Okay, and we're bringing back 3 times 5. So right now, inner, I have 12v, and outer, I have 5v. So there's no way to get 1 out of that. So the only other thing I can do is change the 3 and the 5. But that's not going to help. Can already see it. If I go 5 and 3, inner that's 20, and outer that's 3, that's even worse. Okay, is there any way that putting a 15, like trying the 1 times 15 option, is there any way that's going to help? I don't think so. Best I could do is go like that, and that's 4 and 15. This is looking unfactorable. Okay, so that means, since it's unfactorable, that means that this is really the answer up here. So I'll just erase all this mess. So I tried, but it's unfactorable. So nothing cancels, and that right there is the answer. The excluded values are v cannot equal 1, v cannot equal 3. Okay, so pretty simple. That was number 2. Okay, so here comes number 3. This time it specifically says give excluded values, so we'll definitely make sure to do that. But this is an equation now, so it's a little different. It's not about finding like terms anymore. We're just solving this equation. So there's a new tool that we can use, which is called multiplying through by whatever you want. And so what I suggest is let's look in the denominator and let's multiply by whatever it takes to cancel out all the denominators. So I see a factor of 5, so I'm definitely going to need to multiply everything by 5. I mean, you got to do everything. Whatever you want to cancel out, everything's got to be multiplied. So I'm going to multiply by 5 here. And look, this is like a in parentheses, so I'm going to multiply by 5 up here, and I'm going to multiply by 5 here. But also I see this n squared. Alright, everybody's got an n squared, so I'm going to have to multiply by 5n squared everywhere. Got to make a little more room, I guess. 5n squared. So everything's getting multiplied by 5n squared. Now everything that I highlight right now is going to be canceling out. So in this first fraction, the n squared cancels out. Okay, so that's going to leave behind the 5. 5 times 1, which of course is just 5. Okay, so the n squareds cancel out. Now on this next one, the 5n squared is going to cancel out the 5n squared. Now that's going to leave the n minus 3. Now be careful. See how I put parentheses around it because it's a binomial? Yeah, that's important, because we're going to have to distribute that negative sign. Alright, so don't forget to do that. So yeah, so anyway, over here the n squared and the n squared are going to cancel out. That 5 is still left, so what I'm dealing with is 4 times 5, so that's 20. So again, I'm going to treat this like it's a negative 1, and I'm going to distribute it. So I'm going to get 5 minus n plus 3 is equal to 20. So that's negative n plus 8 is equal to 20. And I'm going to subtract 8 from both sides. So that's going to give me negative n is equal to 12. But then I'm going to divide both sides by negative 1, because you can't have a negative n sitting there. Alright, so that's going to give me n is equal to negative 12. So that's probably the solution, as long as that's not one of our restricted values. So speaking of excluded values, let's look back and see what they were. Looking at these denominators, you know, the denominator can't be 0. So in this case, that just means that n cannot equal 0. Alright, so that's my excluded value. So that's the answer for number 3. Alright, again, let's factor everything we can, which means this. So I've got 2 over x plus 5, okay, equals. Now here we're talking GCF, so this is 2x and then x plus 5. Alright, and then I've got plus 1 over x plus 5. So I see a lot of x plus 5 going on, so that's cool. I don't need like denominators, so that's not what's happening. This is an equation that I'm solving, so what I want to do is multiply by whatever it takes to cancel out the denominator. So every factor, every unique factor that I see, that's going to be involved in what I'm going to multiply by. So for example, I see 3 factors. I see a 2, an x, and an x plus 5. Alright? And the rest, that's duplication, another x plus 5. So I'm going to multiply by 2x and x plus 5. Those are the 3 factors that I've got. So that should be enough to cancel out all denominators. 2x, x plus 5. Okay, 2x, x plus 5. Now everything that I highlight right now is canceling out. So this x plus 5 is going to cancel out this. The entire 2x plus 5 is going to cancel out all of this. And this x plus 5 is going to cancel out this x plus 5. So disregard everything that is now green, because it just got canceled out. So here's the stuff that survives. But we know whatever comes next, there will be no fractions. Notice how all the denominators are green. They all got canceled out. So here I have 2 times 2x, so that's 4x. Here, all I have is 1, alright, but that 1 counts. And then here, I've got 1 times 2x, which is just 2x. So I see these variables on opposite sides of the equation. So let's go ahead and get those together by subtracting. Okay, so that's going to give me, let's see how much space do I have over there. Alright, that's going to give me 2x equals 1, and time to divide both sides by 2. Okay, so that's going to give me x equals 1/2. Okay, so x equals 1/2. That is the solution to this equation. Now let's go back and talk about excluded values, which is also very important. It's all about the denominators, alright, and it's easiest to see in factored form. So because of the x plus 5, x cannot be negative 5, because that would make 0. So x cannot equal negative 5. Is there anything else? Well, because of this x factor right here, x cannot be 0, because that would multiply by everything and turn everything into 0. So x cannot equal 0. So these are the 2 excluded values. So this is the answer to number 4. Alright, number 5. I could treat this problem the same way as the last one, and I could see, oh look, I need to cancel out the x minus 4 factor, so I'm going to multiply everything by that. But I also need to cancel out the x plus 2, so I'm going to multiply everything by that. And then I could cancel stuff out, cancel things out. I could do it that way. But actually, when you just have a fraction equal to a fraction, and we want to solve it, it's easier to think of it as cross multiplying. Alright, and that's where we do the diagonals. So I can do 6 times x minus 4 and set that equal to 4 times x plus 2. Okay, so I'm going to do it that way this time. So that would be 6 times x minus 4 is equal to 4 times x plus 2. Alright, diagonal equals diagonal. Obviously we got to distribute, so that'll be 6x minus 24 is equal to 4x plus 8. Alright, I see the variables on both sides. Let's get them together by subtracting. Okay, so that is going to give me 2x minus 24, okay, is equal to 8. So time to add 24 to both sides. So that'll give me 2x is equal to 32. Alright, and then it's time to divide both sides by 2. Alright, so that'll give me x equals 16. So that is the solution. Alright, as long as it's not one of my excluded values. And looking at these denominators, the excluded values are x cannot equal negative 2. Alright, because negative 2 plus 2 would make 0, and that's no good. And because of this one, x cannot equal positive 4. Alright, because 4 minus 4 again would make 0. So that's it. This is the answer to number 5. On this one, we are just stating the excluded values. We are not going to actually solve it. For that reason, we are going to focus our efforts on the denominator, because that's where the excluded values will come from. So let's go ahead and try to factor the denominator. Okay, now 7p squared can only factor as 7p times p. 9 is either going to be 3 times 3 or 1 times 9. Let's start with 3 times 3 and see how far that gets us. Alright, inner plus outer has to equal middle. Inner, I have 3p. Outer, I have 21p. Can we get a 64 out of that? No. So, got to change something. So, better get to the 1 times 9 scenario. Alright, let's go ahead and jump to it. What if I do 1 and 9 like this? Well, check it out. 7 times 9 is 63. So, inner I have 1p, and outer I have 63p. Ah, okay. That'll make 64 as long as both of these remain positive. Okay, and a positive times a positive is a positive. So, that's brilliant. So we factored it. Now that we factored the denominator, okay, so this has been replaced by this, these cannot be 0. So that means that 7p plus 1 cannot equal 0. Okay, and p plus 9, not 19, p plus 9 cannot equal 0. So I need to subtract 1 from both sides, so that'll give me 7p is equal to negative 1. Divide by 7. Okay, so that's going to give me that p cannot equal negative 1/7. Let me write it. I'm going to put the final answers like over here. So p cannot equal negative 1/7. And of course from right here, simply subtracting 9 from both sides, okay, that's going to give me p cannot equal negative 9. So these are the excluded values, and that's all we were supposed to find for number 6. And that is the end of this quiz, the end of this lesson. I hope it was helpful, and I will see you on the next video.